recording. All right, so we are going to start just reviewing for the free response part of your test. So there's going to be 4 questions. Number 1 is calculator. So go ahead and grab a calculator or get your calculator out, please. All right. Bless you. And so all of the free response questions are 6 points each. So if you look at all how this is set up, then you can tell that each part is 1 point. And it's either all or nothing. You don't get half points. So for example, if they tell you like on AI to do a decimal approximation and you give a fraction answer, do you think you're going to get anything? Nothing, even if you do everything perfectly. So it's super important to pay attention to all the words. This whole thing is 1 point. If you don't do a decimal approximation, you get 0 out of 1. Even if it's yeah. Okay. Yeah. No. All right. So what I would do if I was you is if they give me a function like g that is written as in algebraic form, I would go to y equals, and I would just go ahead and put that in my calculator because more than likely you're going to have to use it multiple times. Okay. So number 1 is going to be similar to this one or similar to the green one that I gave you, where one of your functions is a table and one is algebraic form, or one of your functions is in graphical form and one is algebraic form. All right. And so I'm trying to give you all the different things that you could see so you'll be completely prepared. And so I is going to be very similar to this, where it's a composition function. So it's a whole nother function, h, that is the composition of f and g. So g of f of x. And we want to find h of 4. So on your other sheet, that's the booklet response. We're going to do h of 4, which is going to be g of f of 4. Now, I've seen you guys working some of these on the multiple choice, and you seem to be pretty good at doing the compositions. And so if we're doing g of f of 4, you're going to start with f of 4, which is, what do y'all think? F of 4? 5. All right. Now, all of the perfect samples of solutions have a step right here where they actually take 5 and they put it into g. So they do 5 squared minus 2 times 5 plus 7 over 5 plus 5. So that's what they put in the sample work. I don't know if you have to do that. I do know that I probably wouldn't find the answer that way. I probably would do y1 of 5. Now we have to be super careful because y1 of 5 gives you 11/5. Is 11/5 going to give you any points? If it says to find the decimal approximation, 11/5 is going to give you no points. So it's super easy to figure out what 11/5 is. You just do 11 divided by 5. 2.2. All right. And then on part 2 of this, part A, it tells you to find f inverse of 10. Now, I actually changed Brian Passwater's notation here to be this because I wanted you to see this notation. Unfortunately, this function actually doesn't have an inverse function. Do you guys know why? We're going to talk about it more, but for a function to have an inverse function, it has to be 1-to-1, or it has to pass the horizontal line test. 1-to-1 means that each output is paired with, or came from a unique input value. So what's the problem with this table and that happening? Yeah, that's an issue. So we're going to kind of just ignore that for now and answer this question like it is a function. The inverse is a function. So if we're trying to find f inverse of 10, what exactly are we trying to find? Right. We want to find when this function f equals 10. So I would write f of x equals 10 when x equals 5. So f inverse of 10 is 5. And that's all you have to do. You probably could just say f inverse of 10 is 5, but I want to model perfection here. Okay. And then for B part, we want to find all the values as decimal approximations for which g of x equals 4. So keep straight in your head which is g and which is f. So g is the function we typed into the calculator. And so we're going to go back to that y equals. And what are we going to make y2? Yes. Okay. And so I think you guys were probably doing it while he was making that announcement. So you're just going to do second, trace, intersect, move to the 2 intersections, hit enter 3 times. Did y'all get it? When you're giving decimal approximations where the decimal goes on and on, if you're not accurate to 3, then you get none of your points. So someone in my last class was like, why do we have to write that 0? I thought 0 at the end of the number, you could just drop off. Well, you can't if there's something after the 0. And so your decimal there didn't just stop at 0. There was something after it. So you have to be accurate to 3. So write 4 if you need to, if you're worried. All right, you guys okay? Did you get those numbers? Okay. All right, and then the next part says to determine the end behavior of g as x decreases without bounds, and we're going to express the answer using a mathematical notation of a limit. So decreases without bound, which side are we talking about, the left or the right, if x is decreasing without bounds? Talking about the left side. We cannot depend on our calculator graph. What I've seen from these questions that somebody has made up, Brian Passwater or the AP people, they make this in a way that if you're kind of zoomed in on your graph, you're going to miss it. And so when we first learned this about the end behavior of rational functions, the end behavior can be the horizontal asymptote. Does this one have a horizontal asymptote? I really need you guys to know this. If the degree of the numerator is greater than the denominator, does it have a horizontal asymptote? It doesn't. So we can't give the horizontal asymptote. It doesn't have one. So we did this a long, long time ago. I actually don't expect you to remember this without me reminding you, but you might. What we did to find the end behavior is we would divide the largest degree term of the numerator by the largest degree term of the denominator, and that is how the ends are going to act. So I'm going to write that out, and hopefully when I write it, it's going to refresh some stuff in your memory. So I'm just going to quote the problem for a second where it says, as x decreases without bounds, g acts similarly to y equals x squared over x. So we just divide the terms with the largest degree by each other. And so x squared over x just reduces to x. So that's going to be a line with a slope of 1. So it's going to act similarly to this line. It's not so wobbly. All right. So we were talking about the left side. We said x decreases without bound on the left side. What is the graph going to do on the left side? Decrease without bound. Now that is not enough because it tells you to write the answer as a limit. So we're going to do that. So it's going to be the limit as x approaches negative infinity of g of x is also negative infinity. I think, honestly, if I'm guessing how they're going to grade the test, this might be all you need. But we're not going to practice that. We're going to practice it all, and hopefully you'll put in what you need. All right. And then the next question, we're going to use the table of values of f to determine if f is best modeled by linear, quadratic, exponential, or logarithmic. And so what are we going to do? It's either going to, there's 3 things that could happen, 4 things that could happen. For linear, if we find the first differences, they're all going to be constant value. For quadratic, the second differences will be constant. For exponential, the outputs are going to be proportional, so you're multiplying by something each time. What about logarithmic? The inputs are proportional. Good. All right. So to me, when I'm looking at it, it doesn't look like it's going to be proportional. It looks like we're going to have the differences. So let's go ahead and find the first and second differences if you haven't already. This is with calculator. So if you want to do it with a calculator, you take one and subtract the previous one from it. Or you can just kind of look at how they change. First differences are not constant. However, second differences are. All right, so you would need to write a statement about which is the best model. So I would say something like f is best modeled by a quadratic function. We don't say why here. But the next question, that's where we say why. And so we're supposed to give a reason for our answer based on the relationship between the output values of F and the change in the input values of F. If you don't mention output and input, then you're not answering this question. All right, so when we did this back in, I don't know, August or September, you guys had this memorized, like what you were supposed to do. Someone in my last class still had it memorized. We'll see what you guys remember. So we're going to say because what happened? Do I remember? The second difference is in what part? Wait, not yet. The second difference is, what did we subtract, input or output, to get our second differences? Output. So in the output values are a constant 2. It could be any constant. It could be a positive constant or a negative, as long as it's the same number. Here we go. Over, what do y'all think? What kind of input? Consecutive. Equaling. Input value intervals. A quadratic model is best. Now, I'm pretty confident if you left off because and just said the, you could probably leave off what you already said. But again, I'm trying to model the perfect answer. Okay, so hopefully that felt kind of familiar. We're going to do one that might not feel as familiar. And it's because it asks questions about invertible that we didn't do a ton of FRQs with. So let's do this green one, task model E. All right, so this time we have a graph and a function in algebraic form. We're going to take that function in algebraic form. We're going to put it in for y1. All right, so A1 is almost identical to the one we just did on the other model. It's possible it could be f of g of x, but whatever. These are both g of f of x. And on this one, we're finding h of 3. All right, so if it does tell you some extra information on this one about some points on the graph, if you can, I feel like you can also tell those from the graph, but whatever. So you guys do g of f of 3 on your own already, if you haven't already, please. So at this point, you are welcome to just type that in the calculator, or I know that G is already in there. So you can do y1 of 2. There it is. Be accurate to 3 decimal places, then we're good. All right, y'all good? Y'all get that? Okay. All right, so for second part of A, it says to find all real zeros of f or indicate that there are no zeros. And so from the graph, we're looking to see where the function equals 0 or where there is an x-intercept. So what do y'all think? -1. If you're unsure, it tells you here what you need to know. They're just testing, I guess, that you understand what a 0 is. So we can say that f of x equals 0 when x equals -1. So x equals -1 is a real 0 of f. Okay, and then part B asks us to find all the x values as a decimal approximation for which g of x equals e. So I want you guys to do this one on your own. It's pure calculator. So there's two ways to get e. You can do e to the first power, or just regular e is second and then division. Did you guys get 1.271? All right, part 2 on B says to determine the end behavior of G as x increases without bound. We're going to express our answer as a mathematical notation of a limit. So this time, x is increasing without bound, so we were caring about the right side. And you can just use the graph on this, as long as you understand what a logarithmic graph does. So here's our graph. This left side is going to get closer and closer and closer to the y-axis. The right side is going to just keep getting higher and higher and higher and higher. So as x increases without bounds, the function is also increasing without bounds. So we're going to write that out. May or may not be necessary. We are not going to say the function because there are two functions here, actually three, if we're talking about h of x also. So we're going to say the one they're asking about, which is g. And as a limit, it's going to be the limit as x approaches infinity of g of x equals infinity. Okay, and then for part C, the first part of part C, it says determine if f is invertible. And I don't know if you guys know what that word means. I don't feel like I used it a ton this year, but it means if a function is invertible, then its inverse is a function, and the original function was 1-to-1. Or if you're looking at a graph, it passes the horizontal line test. So what do you think about f? Is f invertible? Yes. So all we have to say is f is invertible. We do not have to say why until the next part. And they were very specific that the reason cannot be the function passes the horizontal line test. The reason cannot be the function is 1-to-1. It has to talk about output and input. And it doesn't say you have to talk about output and input, but we do. And so You're not going to have this memorized, like you have the equal length, all that memorized, because we just haven't done it. Hopefully by the actual test, you're going to feel good about this. But what you're going to say is each output value is mapped from a unique input value. And if f was not invertible, you would say each output value is not mapped from a unique input value. All right, what questions do you guys have on FRQ 1? All right, I'm gonna give you guys 2 to practice on your own. I really wanted you to have more time, but I was kind of slow.